All right, so far we've looked at a bunch of review material from CCDM 114 or from your previous algebra classes. The next two videos are going to be pretty much new material. This is something that we start here, and then you will see this in all of your future math classes. This is going to be one of the key things that we talk about in this course to prepare you for future math classes. And so what is that topic? And so that topic is going to be Intro to Functions. And in this one, we are going to talk about domain and range. All right, so let's just start with some vocabulary and talk about how it pertains to functions. So the first thing that we have is we have relation. Now, relation is basically just sets of ordered pairs. Anytime you state when x is this, y is that, you are using a mathematical relation. So relations can be given in several different forms. You can be given a table, you can be given an equation, sets of points, graphs, and even word problems. If you read the word problems, you're given some information, and that can form a relation. From there, we want to break down our relation into the domain and the range. So the domain is the set of all inputs. And for most of our equations, these are going to be the x values. The domain can be written using a list of values, and we primarily only use this when we are given a table. We can also use set notation with an inequality, or we can use interval notation for an equation or graph. And of course, there are other techniques that we will talk about later this semester, depending on what we're looking at specifically. When writing the domain of a function given a graph, we are going to use interval notation or set notation. And remember that with interval notation, we're talking about the x values. We want to go from smallest to largest. And so we are going to be going from the leftmost x value to the rightmost x value. So that's what we're looking at. We want to find the leftmost point and the rightmost point, and we only want to keep the x values because we are talking domain. Now, if the graph goes forever to the left or right, which is going to be indicated by an arrow, or if the graph goes to the very edge of the coordinate axes, then you will want to include either a positive or negative infinity. If it's going forever to the left, we use a negative. If it's going forever to the right, we use a positive. All right, that is our domain. That is our inputs. The second thing we want to talk about is the range. And so the range is the other one. The range is the set of all outputs, or the y values. And just like with the domain, it can be written using a list of values, again, primarily when we talk about just tables, set notation with an inequality, or interval notation if we're given an equation or a graph. And I wrote this wrong. That should say, when writing the range, so change that in your notes. When writing the range of a function given a graph, we want to go from the bottom to the top. So remember, y values, again, we want smallest to largest, and so our smallest y value is going to be the bottom point, and our largest y value is going to be our top point. And so we want to find the bottom point and the top point, and again, because we're talking range, we only want to keep the y values. Again, if the graph goes forever up or down, we do want to, again, this is going to be indicated by either an arrow or the graph going to the very edge of the coordinate axes. we want to include a positive or negative infinity. If it's going down forever, it's a negative, and if it's going up forever, then it is a positive. All right, so this is going to be the primary focus that we're going to look at in this video, is talking about domain and range. The last thing that we want to talk about is we said that this section was devoted to functions. And so let's talk about what does it mean to be a function. A function is a relation. And again, a relation can be an equation, a table, and or a graph. And a function is a relation in which each member of the input corresponds to only one output. We're going to see lots of examples of this. But this is what we're looking at. We want to see if each x value only goes to one y value. So one of the things that I do want to point out, y values can appear multiple times. We only care about each x value. Okay, so kind of the way that I like to think about it is everybody can go to the same location. Hell, we can carpool. But on the other hand, you cannot go to two different locations at the same time. If we think about the people being the inputs and where we're going as the outputs, that is what we're talking about when we talk about functions. Now, as I said, we're going to be looking at equations, tables, graphs, and so when we look at graphs, we have something called the vertical line test. And the vertical line test is used to determine if a graph is a function. There's two different definitions for this. I'm going to go with the second one, and so the second one says if there is at least one vertical line that passes through the graph more than once, it is not a function. The other definition is every vertical line must pass through the graph at most once. And I don't know about you, but I don't want to test every vertical line. I would rather just try to find one. All right, so let's talk a little bit more about what does it mean to be functions, or why do we care about these things? Functions are used to represent real life situations. So for instance, if we let the students in the class be the inputs, can everyone be registered for the same course? And yes, we can, because we are all here. We only care about what each student is doing, not the collective student body. So let's ask this: can any student in this class be registered for and attending another class that meets at the exact same time? And the answer to that is no. Unless you're Hermione Granger, you cannot do this. We don't have time turners that allow us to attend multiple classes that meet at the same time. All right, so this is kind of our introduction to functions, our vocabulary. So kind of keep these ideas handy as we go through the next couple of examples. All right, so let's go ahead and look at some tables to start off with. These are some of the easiest ones to look at domain, range, and determining if it's a function. All right, so the first thing that we're going to do is we want to identify the domain and the range. So remember, the domain is the set of all inputs. And so it's going to be all of our x values. And so here, for our x values, we have -2, -1, 0, 1, and 2. And kind of the standard notation is we enclose in squiggly brackets. And the squiggly brackets just indicate x equals -2, -1, 0, 1, and 2. Our range, we want to look at our y values. And so our y values that appear in the y column, we have 0, 1, 2, 3, and 4. And we want to know, is this a function? And so to determine if this is a function, we just want to look and see, okay, we're only going to look at each x value. -2, does it go anywhere else other than 0? And the answer is no. -1, does it go anywhere other than 1? And the answer is no. 0, does it go anywhere else other than 2? And the answer is no. And so basically what we have here is if all of these x values only appear once, it is a function. This is what you can do when you were looking at tables. So we say each x value appears only once. Or each x value corresponds to one y value. All right, let's go to table number 2. Table number 2, we want to start by listing our domain. And so we list our x values. Our x values are -3, -2, -1, 0, and 1. Again, we're going to put it in squiggly brackets. For our range, we want to look at the y values. And so for our y values, we have -3, 0, 1, and we're going to stop there. We don't want repeated values. We just want to know, okay, what can y equal? And so y can equal -3, 0, and 1. We don't care if it appears once or multiple times. And now the question is this a function? And so even though we have a couple y values that appear multiple times, remember that domain or function, we only care about the x values. And so when we look at our x values, our x equals -3, does it go anywhere else other than -3? And the answer is no. And if you do this with the other ones, we still are okay. -2 only goes to 0. And even though 0 goes to 0, these two guys can go ahead and carpool and take a car together to get to the same location. And so that's okay. And so, yes, this is a function. And again, we say each x value appears only once. Okay, so again, y values, we don't care about them. They can do whatever they want. They can appear as many times as they want. We only care about the x values. All right, let's go down to the last table. In the last table, we have, for our domain, we have -3, 0, and 1. And again, we don't want to repeat any values. We just want to know what can x equal. And these are the 3 values that it can equal. For our range, we have -1, -2, -3, -4, and -5. All right, so now, is this a function? And this one is not. So kind of to compare table 2 and table 3, what do we got that's different? Here what we have is we have -3 is going to -1, and it's also going to -5, and that's not allowed. You can only go to one number in order to be a function. And so same thing, we also have 0 goes to -2, and 0 goes to -4. And we don't have to keep track of both of these. We just need one in order to say not a function. So we can just say -3 goes to -1 and -5, and this violates our definition of function. All right, so table 2 and table 3 give you a good indication of what it means to be a function, what's not a function. I do want to go back and talk about table 1. And table 1 is actually a special type of function. And we'll talk about this one later, but this one we refer to as being one-to-one. And one-to-one is something that we'll talk about at the end of the semester. It's a special type of function where we have x values appear only once. That's our function. And we have y values appear only once. And so if you have this, it's a special function called one-to-one. All right, that takes care of our tables. Let's go to our next examples. Right. The next thing we want to look at is we want to look at some graphs. And we're not going to come up with domain and range on these. We just want to look at these pictures and determine if it is a function. So the first one, I want to know, is it a function? For each one of these, we're going to use the vertical line test. Vertical lines go up and down. And so I want to know, can I draw a vertical line through this first graph that crosses more than once? That only crosses once, 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 once. Note that there is no vertical line that I can draw through this graph that will cross more than once. So this is a function. If we come to our second example, I want to know if this is a function. And so here's the thing. Here is that's a horrible vertical line. Here is a vertical line. Note that it crosses the graph at more than one point. It crosses twice. And I just need to find one single line that does this in order to disprove function. So this is not a function. The last example, if we go ahead and look at this, can you find a vertical line that will cross through the graph more than once? And the answer is no. This is a function. All right, so those are some examples of pictures of functions and not functions. So now let's go ahead and play around with domain and range. Next thing that we're going to look at is equations. So I'm going to go ahead and tell you which one of these are functions and which are not. And we're going to kind of talk about, okay, so what are we looking for? The first one we have is this is a function. This is a linear equation. And it actually is a linear function. One thing to note is all lines except for vertical lines are going to be functions. So the only linear equation that is not going to translate into function is x equals some number. All right, if we look at the next one, x squared minus 5y equals 4. This is a function. We will be studying these later this semester. We actually call this a quadratic function. All right, y equals 3x minus 4 over 2x minus 5. This is a function. We actually call it a rational function. Okay, on the bottom, we have x squared plus y squared equals 4. Now this is not a function. If you graph this, this actually is the graph of a circle. And so what makes this not a function? What's one of the things we want to look out for? Right here, y squared. This makes this not a function. If I plug in y equals 1 and y equals -1, I get the same thing. And so we run into problems right here. Okay, so if ever you see a y squared, you can automatically state not a function. Okay, y equals the square root of 3x minus 5. This is a function. And we actually call it a radical function. And the last one, y equals 2 to the x. This is a function. This is one that you probably have not seen before. We will be looking at these later on this semester. This is known as an exponential function. Now, this class is based mostly, we're going to be talking about functions. So you will probably see things that are not functions later on in your studies. But basically, everything that we're going to look at this semester does fall under the category of function. Okay, so now let's look at our graphing examples. And so the first thing we want to do is, if you double check, all of these are going to be functions. They do pass the vertical line test. And so we want to just talk about domain and range. And so remember that domain is x values, and domain goes from left to right. So for instance, when we look at graph 1, we have a leftmost point here, and the coordinates of this point are -5, -2. If we go all the way to the right, we have a rightmost point here, and the coordinates of this point are 4, 4. And so when we go to list the domain, remember domain, we only want the x values. So all we care about is our -5 and our +4. Now, though there are examples that we will see later and probably in future math classes, for now, we are going to put square brackets around both of these. The only time that you will use a parenthesis around a number for now is if it has an open circle. But if you look back at the original graph, it was, both of them were closed circles. So this is in interval notation. If we want to write it in set notation, we have x, and we have that we are starting at -5. We want this to be less than or equal to x, and we want that to be less than or equal to 4. This is the numbers in between -5 and 4. All right, so that is our domain. So now we want to talk about the range. And so for our range, remember that we want to go bottom to top. And so the first thing we want is, where is the lowest point? And so our lowest point is right here. Notice that it's not the same thing as the leftmost point. That's not necessarily always going to be the case. If we write the coordinates of this point, this is -4, -3. We want our highest point, and our highest point happens here. And the coordinates of this point are 3, 5. For our range, remember range, we care about y-coordinates. And so our range, remember we want bottom to top, is going to be -3, 5. And again, we want to put this in square brackets. If we write the range in set notation, just a reminder, make sure that you're very careful about your letters. Remember, range is the y values, so we're going to do squiggly bracket y with a vertical bar, and then we want -3 less than or equal to y less than or equal to 5. That is our domain and range for graph 1. All right, let's go down to graph 2. Graph 2 looks like this. And so we want to start with domain. Notice this one has arrows. And if you go back to the earlier post that had all the definitions and key terminology and stuff, we have to think about these arrows. And so one thing to note is, majority of the time, arrows are going to go in two directions. And so you have to think about these arrows in terms of, are we looking at domain or are we looking at range? For this one, we'll start with the domain. And when we look at these arrows, remember domain is left and right. This arrow goes forever to the left. Remember, we are on the negative side of our y-axis, which means that this goes forever towards -infinity. Okay, we want to know how far to the right does this thing go. And if we trace around, we're going from left to right, we come over here and we see another arrow right here. This arrow keeps going beyond the coordinate axes, and it keeps going to the right. Since we are on the positive side of the y-axis, this goes to +infinity. All right, now if you want this in set notation, all we're going to say, we don't have infinities in our set notation. All we're going to say is x is a real number. Or all real numbers, just something that says that x can be anything. All right, that is our domain. Now we want to go to our range. So our range, we want to figure out, okay, starting at the bottom, what do we got? We start here. This is my lowest point. And remember that we want to keep the y value. And so our range is going to start at -3. It's included because it is a solid circle. And then we want to know how far up does this go. And so it doesn't matter which direction you go. Both of these go up. And if you notice, we have these arrows at the top. So not only do these arrows go left and right, but both of these arrows go up forever. Our y values up here are on the positive side of the x-axis, and so they are going towards +infinity. if we write this in set notation, we have y, and this is going to be y is greater than or equal to -3. Again, don't put infinities in your set notation. All right, that is graph 2. All right, these are our first 2 examples, and so now let's go ahead and look at a couple other ones. All right, if we come to graph 3, we have something that looks like this. And so we're going to go ahead and start with our domain. All right, so domain, remember, left to right. And so when we look at this, starting on the left, I do see an arrow right here on the very left side of my graph. Again, we're talking x values, and so we're looking at these numbers here on the bottom, and this goes forever to the left. And so that is going to be -infinity. And again, we want a parenthesis. All right, how far to the right does this go? Well, if we go to the right, it stops right here. And remember that when we talk domain, we want the x value. And so our rightmost x value is going to be 3. If we write this in set notation, we have x such that we want all the values that are less than or equal to 3. All right, so now let's look at the range. So remember, range, we're going to go bottom to top. And so if we start at the bottom and start going up, the first or our lowest points happens at 3, 0. Now remember that for range, we do want the y value, and so we want to start at 0. So that's going to be our first number. This is our smallest value, our lowest value, and then we want to know how far up does this go. And so if we look at our graph, this goes up, 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 up. And even though it looks like it's getting shallow, it actually does keep going up. And so this is going to go towards positive infinity. If we write this in interval notation, or sorry, set notation, remember range, we want y. And then we have y is greater than or equal to 0. All right, that is graph 3. We got one more to look at, and so if we come down to graph 4, we have basically a linear function. Okay, so when we look at this, this one's going to be pretty easy. I'm not going to do set notation, I'm just going to do interval notation. And so for this one, we want to know, okay, how far to the left does this go? And if we come over here, we notice that our arrow is going to the left. Remember that these arrows go 2 directions. This goes forever to the left. We are on the negative side of the y-axis, and so our domain is going to go -infinity to the left. And then if we go to the right, notice we have another arrow up here on the top, which means that this graph goes forever to the right. We want parentheses around both of our infinities, and that's your domain. All right, now, if we talk about the same line from the range perspective, remember we're going bottom to top. And so when we look at this arrow, we want to kind of change our perspective. Now I want to think about this arrow as going down forever. And so our range, how far down does it go? It goes down to -infinity. And if we go up, How far up does it go? Again, we have another arrow, which means that this goes towards positive infinity. If you want to write in set notation for both of these, it's just all real numbers, or x is a real number and y is a real number, something to indicate that you can plug in any number. Now, we'll talk about this a little bit more in the next sections coming up when we talk about linear functions. But if you have a linear function that has a slope that's either going to be increasing or decreasing, it goes up or it goes down, then what you have is your domain is always going to be negative infinity to infinity. And similarly for your range is always going to be going negative infinity to infinity. It's always going to be going forever up and forever down. It's always going to be going forever left and forever right. But we'll talk about that a little bit more later. All right, so now that finishes off our talk about domain and range. The next thing that we're going to be talking about is function notation. All right.